Welcome! Today we're popping the hood on a Spring Boot application. We're going to get right into the nuts and bolts and see what makes this thing tick and how just a couple lines of code can spin up an entire fully functioning application.
So this is where it all begins. And at first glance, it looks almost too simple, doesn't it? You've got one annotation and literally one line of code in your main method. And somehow this launches a whole web server. How is that possible? How does this tiny snippet pack so much power? Okay, let's really dive in and find out. Our investigation has to start with that single annotation, at Spring Boot application. The absolute best way to think about this is like the engine control unit, or the ECU, in your car. It's the central computer, the brain, that coordinates and manages everything else. But here's the first surprise. When you actually look under the hood of at Spring Boot application, you find out it's not one thing at all. It's a composite annotation, kind of like a combo deal. It's a convenient package that bundles 3 other incredibly powerful annotations that all work together. So let's break down what each of these 3 does. First up, we have at Spring Boot configuration. This one's pretty straightforward. It's basically just a big signpost. It tells the Spring framework, hey, you, start looking here. This class is a source of configuration. It marks the spot as a place where you'll define some of the application's core components, which Spring calls beans. Next in the bundle is at component scan. You can think of this as Spring's detective. Its whole job is to go out and scan through your project to find all the custom components that you've written, things like your web controllers, your business services, and so on. It finds them and automatically registers them with the application. Now, this brings us to a super important point, a golden rule, really. In Spring Boot, your project structure isn't just for organization, it's a form of configuration itself. As long as you put your main application class in a top-level or root package, the component scan will automatically find everything in any package nested underneath it. It's simple, it's clean, and it just works.
And on the flip side, this slide shows the #1 mistake that trips people up when they're starting out. If you put a component in a package outside of that main application package, the component scan won't see it by default. As far as Spring is concerned, that component just doesn't exist. So remember, package structure is key.
And that brings us to the third and honestly the most powerful annotation of the bunch, at enable auto configuration. Seriously, if you've ever heard someone talk about the magic of Spring Boot, this is what they're talking about. This annotation tells Spring to take a look at the libraries you've included in your project and then make smart, educated guesses on how to automatically configure things for you. Okay, so we've looked at the engine's control unit. Now let's talk about turning the key in the ignition. That happens right here in the main method. Without one line, SpringApplication.run. This is the command that kicks the whole engine into life. You know that one little run method? It kicks off this whole perfectly timed liftoff sequence. It figures out what kind of application you're building, it prepares the environment, it creates the heart of the application, called the application context, and then, you'll see in step 5, it refreshes that context. That refresh is what triggers the component scan and the auto configuration we just talked about. And it all leads to the grand finale, starting up an embedded web server like Tomcat. So that leaves a big question, right? How in the world does that auto-configuration magic know what to do? The secret instructions, the DNA of your project, are all hiding in plain sight in your project's blueprint, the Maven pom.xml file. And inside that pom file, there's this secret weapon, really. It's called the Spring Boot starter parent. By saying your project inherits from this parent, you get a whole bunch of sensible defaults. But more importantly, you get access to a massive, curated list of compatible library versions, which takes all the guesswork out of managing your dependencies. And this parent setup creates a really important distinction you have to understand. The dependency management section, which comes from the parent, is like a price list at a store. It just tells you the version of a library you would get if you asked for it. The dependencies section, on the other hand, is you actually putting an item from that price list into your shopping cart. That's what actually adds the library to your project. Okay, but here's where it gets really powerful. When you add a single starter dependency, like Spring Boot Starter Web, it's just the tip of the iceberg. Because underneath the surface, your build tool, Maven, goes and pulls in everything else that starter needs to work. These are called transitive dependencies. So you ask for one thing, the web starter, and you get everything you need, like a JSON library and, as you can see here, a fully embedded Tomcat web server.
All right, so let's put all these pieces together. We've got the starters from the pom.xml, and we've got the auto configuration process. Now we can finally see how they create this amazing and really elegant feedback loop. So what exactly is a starter? Well, the best analogy I've ever heard is a meal kit. You want to cook a specific dish, so you order the kit. It comes with all the pre-portioned ingredients and the recipe card. A Spring Boot starter is exactly like that. It bundles all the common libraries you need for one specific job, like building a web app.
Okay, step 1 of this loop. It all starts with you, the developer. You decide what you want to build. You say, I want to build a web app. And you declare that intent by adding the Spring Boot Starter Webmail Kit to your project's blueprint, the pom.xml. Step 2, Maven, your build tool, sees that you added the Webmeal Kit, so it acts like your personal shopper. It goes out, gets all the ingredients, all those transitive dependencies, like the Tomcat server jar file, and puts them on your application's class path, which is basically the kitchen counter where your code will be prepared.
Step 3. We hit the ignition switch. The application starts up, and remember our friend at Enable Auto Configuration, it starts scanning that kitchen counter, the class path, and it sees, hey, look, there's a new ingredient here I haven't seen before, the Tomcat jar.
Step 4. That discovery is the trigger. Finding that Tomcat jar on the class path is like flipping a switch. A special auto configuration class, in this case, Servlet Web Server Factory Auto Configuration, suddenly wakes up and says, aha, the recipe calls for a web server, and I see the Tomcat ingredient. I know what to do.
And finally, the result, the payoff for this whole cycle. You get a fully configured, running, ready-to-go Tomcat web server created for you. And you didn't have to write a single line of server configuration code to make it happen. That right there is the core magic of Spring Boot.
Okay, this magic is amazing, but it leads to an obvious question. What if I don't like the default? What if I need my server to run on a different port, or I need a custom setup? Well, the good news is, while Spring Boot has its opinions, it always lets you take the wheel.
You are never locked in. You've got a few ways to stay in control. First, if an auto-configured component isn't quite right, you can just define your own. The auto configuration is smart enough to see your version, and it'll just back off. For simple tweaks like changing the server port, you can just add a line to your application.properties file. And if you really just want to tell a piece of auto configuration to not run at all, you can explicitly exclude it. You're always in the driver's seat.
So there you have it. We've completely taken apart how the Spring Boot engine gets built and started, from a single annotation all the way to a running server. But that just answers the first big question. The next one is, once all those parts are created, how do they find each other? How does a controller talk to a service? How do they all work together? Well, that is the power of dependency injection. And that is exactly what we're going to break down next time.